Ever pondered why tides rise and fall? Is it just a cosmic dance between the Earth and the Moon? Welcome to the Great Tide Debate. Picture this. The Moon, suspended in space, exerts a gravitational pull on our Earth, tugging at every atom, every molecule, every drop of water. This tug of war, according to popular belief, is what causes the rise and fall of ocean tides. Intriguing, isn't it? This theory is widely accepted and taught in schools around the globe. It's a story we've all heard, and on the surface it seems to make a lot of sense. Let's delve a bit deeper into this, shall we? If you've ever spent a day by the sea, you've likely noticed the ebb and flow of water, the rhythmic dance of the tides. High tide, low tide, high tide, low tide. It's a pattern as predictable as the rising and setting of the sun. And this pattern, interestingly enough, aligns with the position of the Moon relative to Earth. When the Moon is directly overhead or on the opposite side of Earth, we experience a high tide, and when it's at a right angle to the Earth, we see a low tide. This alignment, this correlation between the Moon's position and the tide timings, has led many to conclude that it must be the Moon's gravity causing the tides. But here's the twist. What if this widely accepted theory isn't the whole story? What if there's more to this cosmic dance than meets the eye? What if the cause of tides isn't solely due to the Moon's gravitational pull? The world of science is full of mysteries, and sometimes the answers we accept aren't the only ones. Sometimes they're just the ones we've found so far. Theories evolve, perspectives shift, and what we once took for granted can suddenly be up for debate. So let's question, let's explore, and let's dive into the fascinating world of tides. But wait, what if we told you this moon gravity theory might not be the whole truth? Let's take a closer look at some inconsistencies in the moon gravity theory. Now, conventional wisdom tells us that the moon's gravitational pull is responsible for the ebb and flow of ocean tides. But if this were true, wouldn't we see similar effects on all bodies of water, including lakes and rivers? Take the Mississippi River, for instance. It's a massive body of water, yet its surface remains as flat as a mirror, unaffected by the supposed pull of the moon's gravity. How does the moon gravity theory explain this anomaly? And then there's the Bay of Fundy, located on the Atlantic coast of North America. It's renowned for having the highest tidal range in the world. At high tide, the water level can rise up to 50 feet on the eastern end and 20 feet on the western end. 6 hours later, the water level falls back to its original state. Now, if the moon's gravity is the driving force behind these tides, how can it cause a 50-foot rise on one end of the bay and only a 20-foot rise on the other? Furthermore, have you ever wondered why there are no tides in certain parts of the ocean? If the moon's gravity is powerful enough to cause these drastic changes in water levels, wouldn't it affect all parts of the ocean equally? These inconsistencies pose serious questions about the validity of the moon gravity theory. It fails to explain why the gravitational pull of the moon selectively affects certain bodies of water while leaving others undisturbed. It also doesn't account for the varying tide heights in different parts of the world. So, if it's not the moon's gravity, then what causes tides? It's time to challenge conventional wisdom and explore other plausible explanations. After all, science isn't about accepting theories at face value. It's about questioning, probing, and seeking the truth, no matter where it leads. Consider this. What if tides are a local phenomenon caused by the thermal expansion of the Earth's crust? Quite an interesting proposition, isn't it? Rather than attributing the rise and fall of sea levels to lunar gravity, this theory proposes that it's the Earth's crust itself that's responsible. As it warms and cools, the crust expands and contracts, causing the sea level to change accordingly. This gives the illusion of tides. In this perspective, the inconsistencies that riddled the lunar gravity theory are effortlessly explained. The varying tide heights in different locations? Simply the result of varying degrees of thermal expansion in different parts of the Earth's crust. The twice-daily ebb and flow? A response to the daily heating and cooling of our planet. So next time you watch the tides, remember it might be the ground beneath your feet causing that ebb and flow, not the moon in the sky.